Let's discuss this problem and then we'll do it. Okay. So these are the initial conditions that we right at t equals to 0, x1 is 0, v1 is v naught, and so on. So we want to calculate the distance traveled by the particle in time t. Okay. They want us to calculate the distance and what is given? Acceleration is given. Right. So as Akib was suggesting that from acceleration we want to reach this distance. So first, when we integrate, we'll get the velocity, and then second time when we integrate, so then we'll get the distance. So which means that we have to integrate it two times, right, guys? Am I
Yes,
correct?
sir.
Okay, so acceleration is given, right? A is pt. Now we will integrate. So to calculate v, right, from this is v naught to v. Okay, so let me write. So a is dv by dt, right? So dv is a dt. Am I correct, guys?
Yes, sir.
Now we will integrate in both these sides. So in here, what is the limit? So in the left hand side, the limit is on which variable?
X.
So the limit is on this v variable, velocity,
Oh, sorry, sir.
right? So initially, the particle starts from the origin with an initial velocity v naught. So it is starting from v naught velocity, right? This is initial, and finally the velocity is at some point, correct?
Yes, sir.
And time is what? Time is it is starting from 0 to t. Understood? So
Yes, sir.
what is the integral of dv? This is the direct integral. This we have talked so many times. So what is this integral? Yes,
X.
x, right? So similarly, good. So this is v. Understood?
Yes, sir.
So this is v. So this is in the limit from v to this v naught, right? So this integral is done. Now this is from 0 to t, and this is bt. So b is constant and the integral is on t. So you guys quickly calculate and tell me what would be the integral. What is the integral of t? Yes. What is the integral on what is the integral t?
Calculating, sir.
Yes. This is an algebraic function, so you guys check. And yeah, Khudeja, if you have any question, any doubt, so you can ask. Okay. Yes. What did you guys get?
Nothing, sir.
Nothing. So, what is the integral of x? Well, let me write xn. What is this integral xn?
H.
Xn. Xn.
N. N.
Yes, xn. What is the integral of xn?
N.
This is xn plus 1 divided by n plus 1. Right. So this is t, power is 1. So this would be t 1 plus 1 divided by 1 plus 1. So this would be t square by 2. Is this clear?
Yes, sir.
So this is dt. And whenever we have calculated this integral, so now we put the limits. So what would be? First we put the upper limit. So upper limit is v, and then lower limit is naught. So this is v minus, right? And we have calculated this integral. So this is t square, and from t, this is the upper limit. And so when we put this limit, this is v minus v naught. So v minus v naught is v, and first we put the upper limit. So this is t square and minus lower limit, so 0 square. Right? Function is t square. So this will be v minus v naught, and this is dt square. So your velocity is what? Your velocity is v naught plus vt square. Got disconnected. Khudeja got disconnected. I don't know. Yeah. So this is my velocity, guys. Right.
Yes, sir.
Okay. So if I ask you that, if I ask you that this is my velocity, and if I want to check whether I am consistent or not, right? If I want to check whether I am consistent or not. So if I calculate the acceleration from this velocity, what should I get? If I calculate the acceleration from this velocity, what should I get? I should get Vt. Am I correct?
How, sir? BT?
Oh, this is t by 2, right? So this will be t by 2. Yes, how? Vt, because acceleration is Vt, right?
Yes, sir.
Acceleration is Vt, so we should get, if we calculate the acceleration from velocity, so we should get what? Vt, right?
BT. Yes, sir.
So you guys, how can we calculate the acceleration from velocity? What do we do?
Integration.
From velocity to acceleration, we are calculating acceleration.
Degradation.
Differentiation.
Yes, sir.
Right? We are going from velocity to acceleration. Right. So downward is differentiation, and who got discussed? Yeah. Okay. So let us quickly check. I have this v and this v naught plus vt square by t. So if I differentiate, this is dv by dt. So d by dt of v naught plus vt square by t. So this is dv naught by dt plus dvt square by 2 by dt. So v naught is constant. So what should be this? This is
Sorry,
constant.
sir.
This v naught is constant. So what is this differentiation?
T.
This v naught is a constant. So what is the differentiation of a constant quantity? Rishita, what is the differentiation of a constant quantity? Yes,
Sir,
Rishita,
0.
0, right? So this is 0. B is constant, b by 2. So b by 2 is taken outside, and t square
d
differentiate.
square by dt.
Yeah, dt. So t square by dt. So t square differentiation is what? 2t, right? So 2 cancels, and what do I get?
BT.
So this is the correct answer, right? Okay, so we have checked this that we are going in the right direction. Now we have velocity. We have velocity and we want to calculate distance. So we have velocity and we want to calculate distance. So what do? We integrate, right? So what we know? We know that v is dx by dt, right? So then we have this dx, which is v dt. Okay, we integrate both sides. So this position is from 0 to x, or let me write s. Okay, some distance. And then time is from 0 to t. So you guys quickly calculate this integral and tell me the answer. What do you get? Half part I have done. And you guys have promised that 50% is my part and 50% is your effort. So you guys calculate and tell what do you get.
Okay, sir.
And remember, what is the value of p? So p you already put the value of p, integrate, and then tell. Yes, Khudeja. So you can write if you're not comfortable in the microphone, so you can write it in the chat box whether you are understanding it or not. So have you learned differentiation and integration before, Khudeja? Oh yeah, Martin's mic is working now. Hello, Martin.
Hello, sir.
Yeah, good afternoon. Good afternoon. Yeah, so we were doing that problem that I gave you as the homework, 12th problem. Remember, Martin? So did you try that problem? Yes, Martin. Did you try that problem?
Yeah.
Okay. So we are just doing that problem, and I couldn't hear you properly, so I guess you said yes. So what we'll do is that we'll get the final answer, and then you check. You tell us that whether we are correct or not. Yes, Saqib, Rishita, and Khudeja, if you know integration, then you please also calculate. Right,
Yes,
because
sir.
in your CBSE course, Khudeja, you must have done the integration. So what I will do is that in today's class, I will try to complete this kinematics of motion in 1D, right? So that in the next class, we will do the uniform acceleration and then free fall and then what? So then it will become relative velocity. If you have yeah, relative velocity also. Yeah, did you guys get anything? Rishida and okay, Martin, you also calculate
No, sir.
what is happening. Okay, yes, Rishida, did you get anything?
No, sir.
Okay, so dx is x, right, from s to 0 and v naught. This is v naught plus square by 2 and then dt from 0 to t. So this we have to calculate. This is s minus 0, right? Which is this? So this is we have to calculate. So first integration is 0 to t v naught dt. The second integration is bt square by 2 dt and from 0 to t. Okay. So you guys tell me what should I get. This is constant, so this is taken outside.
0.
0.
Yes, sir. It is constant, so it will be 0, right?
This is integration, sir, not differentiation.
Okay,
Right?
sir.
You told me that integration of dx is x, right? Right?
Yes, sir.
Okay, so and then this is t square dt. So let us quickly calculate. This would be, and you guys tell me whether I'm doing it correct or not. So this is t from t to 0 and then b by 2. And what is t square? Integral of t square is what, guys? This is what? Integral of t square.
Sir, t square minus 0 square.
No. Integral of t square. First we integrate, then we put the limit, right? Yes,
T square will be outside.
t square is function. This is so t is variable, right? The integration is on t with respect to t. So this is right. Algebraic function x n dx. This is x n plus 1 divided n plus 1. So this is t 2 plus 1 and 2 plus 1. So this is 2 t cube by 3. So this is t cube by 3. Right. So this would be what? V naught and then t minus 0 and 3 is taken outside. So v by 6 t cube and then t to 0. So this is t cube minus 0. So this would be what? V naught t plus v by 6t. This is our distance. Any doubt in this, guys? Yes, Rishra.
No, sir.
Martin, did you get this one?
Yeah.
So if you guys have any doubt, you guys please ask me, and then this one would be the answer, right? See.
Yes, sir.
Okay, so please note it down, and then we'll do the next process. Okay, 14 and 15 are the same type of question, so I will skip 15 and I will do only the 14 one.
So can you scroll down?
Whenever you guys have completed noting it down, please, you guys please tell.
Finished, sir.
Rishla, Martin, Khudeja, what about you?
Yes, sir.
Yeah.
Let me quickly erase this and then. And you guys also, so this is Rishita's turn, right? So first question is my turn, Rishita, then Akif, then Martin, and Khudeja has just joined, so from the next time we'll ask. Okay, so remember what do we need? We have to remember that first thing is that we want to have what are the limits, right? So first we write what are the initial conditions, okay, and then we know that what should we do? Should we differentiate or should we integrate, right? And then we'll get the answer. So these are the things that we need to remember. Okay, so the 13th question. And Rishita, this is your turn. So a body starts from the origin and moves along the x-axis. So this is motion in 1D, 2D, 3D, in what dimension? 4D. How many dimension the body is moving? The object is
1D.
1D, right? So it is moving in 1D. That is why we have only this x in x direction. So x is given, which is 4TQ minus 2. And t in second velocity, what is the acceleration of the particle when it is 2 meters from the origin, right? So what is given?
The velocity, instantaneous velocity.
Yeah, so velocity at a, oh, so this is velocity is right. So velocity is given, and what is the acceleration of the particle when it is 2 meters from the origin? So x is given, which is 2, right? So this is, and we want to calculate, right? We want to calculate what? We want to calculate a, right? When x equals to 2. So this is a very cross correlated question. First, they have given that velocity at instant is this, right? And they want us to calculate acceleration. Okay. So, but they have given that the position is 2 meters from the origin. So they have given that the x distance is 2 meters, right? So first thing is that what we can calculate from velocity. So we can calculate the acceleration from velocity by what? Should we integrate or differentiate?
Integrate.
Okay, so this is x, v, and a. So when we calculate acceleration from velocity, what do we do?
B minus U by T.
Yeah, so dv by dt, right? We differentiate when we want to calculate acceleration, right, Rishta?
Yes, sir.
And when we want to calculate velocity from acceleration, then we integrate. So remember that when we go from down to upward, then we integrate. When we go from when we go downwards, then we differentiate. Similarly, in this way, we differentiate, and when we go upward, we integrate. So always remember. Okay. So why did I say that this is a cross-correlated question? that we can calculate the acceleration from velocity, right? So from here, we can calculate the acceleration. So you guys calculate acceleration and tell what is acceleration. You guys calculate. Yeah. Rishita, Martin, Akif, Khudija, you guys calculate and tell me what is the acceleration. Yes, are you guys calculating?
Yes, sir.
Guys, this is differentiation. Differentiation is rather easy than integration. So quickly calculate and tell.
Sir, 12t square.
12t square. And what about that? So what did this guy do to you? Huh? What is the problem with this term? So yeah, this one is d by dt of, yeah. You are halfway correct. So this is d by dt of 4tq.
Sir, 12t square minus 2.
Yes, absolutely right. Good. So yes, Rishita, Martin, and Udeja, are you guys getting the same answer? Are you guys getting the same answer? Yes.
Yes, sir.
Good. So now you see they are asking that what is the acceleration when x is 2 meters? They have given the position, but in this part, when we have this relation, so to calculate the acceleration, what do we need? Yes, guys,
Why,
what do we?
sir?
Yeah, we have this relation. So in this relation, acceleration is related by what variable?
Velocity?
Times time. By looking at this relation, we can say that this acceleration is dependent upon time, right?
Yes, sir.
So it is related with time. So when I give you like 2 second, 3 second, 4 second, then you guys can easily calculate acceleration, right? So we need time to calculate the acceleration, correct?
Yes, sir.
So now this is in the question they have given about the distance, right? So this is velocity and they have given the distance. Okay. So we need to calculate the relation between this velocity and distance. Okay. So what is given? How can we calculate the distance from the velocity? What should we do? We have velocity
Integrate?
integrate, right? So dx, or let me write it this way, that v is dx by dt, right? So dx is v dt. So now you guys tell me that what is the what is the initial condition that you have? What is the initial condition? For time, what is the initial condition? And for distance, what is the initial condition? So a body starts from the origin. So what is the initial distance? What is the initial
So
distance?
it starts from 0.
It starts from zero. So this is zero, right? And time is also starting from zero. And let's say that this is S and this is T. Understood? Any problem in that?
No, sir.
So this integral, you guys know, this is x from S to 0 and V is 4t cube. So you guys quickly calculate and tell me what would be this integral. You guys quickly calculate and tell. Yes, you guys quickly calculate and tell me the answer.
Yes, sir, calculating.
Very you guys can see that from here it is a very simple looking question. We only have to figure out time, right? But time we can figure out from here. So what did you guys get? What did you guys get?
Doing, sir.
Yes, Rishita and Martin, Hudeja, you guys can also tell me whether you have calculated or not. Did you get the solution or not? Yes. Any answers? S is what?
Sir, it will be S minus 0, right?
Yeah, S minus 0. So S minus 0 is S. So this would be what?
Sir, it will be integral of 4t cube dx dt.
Minus 2t. So what would be the integral? I'm asking that what would be this integral?
That will take little bit more time.
Hmm. So you guys check that this would be t4 minus t square. Okay, this would be the integral. Clear? Is this clear?
Yes, sir.
Okay, so this would be the distance, right? This is the distance. But in the question, what is given? The distance is 2 meters.
Yes,
So
sir.
this is 2 and this is t4 minus t square, right? So this equation will give us what? This equation will give us what?
Time.
Time, right? Remember, we need time to
Right.
calculate, yeah, we need a time to calculate this acceleration. So this is t4 minus t square minus 2 equals to 0. So the 10th class, so this equation is not a 10th class question, but a 10th class question. What is the degree of this equation?
So it is 4
Degree is
square
4.
and 1.
So
Oh,
degree is
degree.
degree is
Yeah, 4.
degree is 4, which means that how many zeros would be there?
4.
So 4 zeros, right? Which means that we have t equals to 4 solutions, 4t, right? So
Yes, sir.
how do we solve this equation? This is not a quadratic equation, right? You guys know to solve the quadratic equation. So we have to calculate the time so that we can calculate acceleration. So what we can do here to calculate or to solve this equation? Any idea
Sir,
that is yes, yes.
can we use splitting the middle term?
So we know this. So this splitting the middle term is for the quadratic equation, right?
Yes, sir.
Is this the quadratic equation?
No, sir.
Yes. Then how can we solve this equation? You are. Let me give you a hint, Akif. You are halfway there. We have to solve the quadratic equation, but this is not a quadratic equation. So this is your hint.
Sir, you have to divide each term by t.
Each term by t. Okay. So this is if I divide it by t by t and then 0 by t. So this becomes t cube minus t minus 2 by t in 0. So does this solve the purpose?
No, sir.
Okay, so any more idea? Yeah, try. You can, yeah. So any idea that is coming to mind? This was in one idea. Rishita, Martin, and Khudeja, can you guys think of any idea? Right, we are working on the problem solving skills, so we can solve, but we can understand many problems, but we have to get the idea of the solve. So what we can do here in this question, we have to get time, but how can we solve this question? We only know the quadratic equation. We are simple people, so we only know the quadratic equation. Solution of quadratic equation. We don't know the cubic solution, and this is 4-degree equation solution. Yes, Rishta, Martin, any idea? Okay, so let me take you guys back to your 11th class. So in your 11th class, did you guys study about the equation reducible to linear equation? Did you guys
No, sir.
huh? So that was not in your syllabus. Okay. So then let me. So you guys correct me if I am saying something, if I say something wrong. So if I put t square equals to p, okay. So what would be this equation?
Sir, p square
Yes.
minus p minus 2.
So now is this equation simple or not?
Yes, sir.
Who got disconnected? Martin got disconnected. So you guys solve this equation and tell me the answer. What would be the answer? You
Okay,
guys,
sir.
yeah, you guys solve this question. This is a quadratic equation. ये तो आता है तुम लोग को.
Yes, sir.
Yeah. So what is the value of p that you will get? Yes. What is the p that you guys are getting? What is the value of p? Okay, Brishita, Kudeja, any answer?
2 minutes, sir.
So
Yes, yes, Brishita. Two. Okay,
Sir, p is minus 1 and 2.
minus one and two. Okay, good. So, yeah, Rishita and Akib are getting minus one and two. Right, so alpha and beta is what? This is minus b plus minus b square minus 4ac by 2a, right? So minus b, this is 1 plus minus b square, which is 1 minus of what? 4 into 2 into, right? So this is plus 8 and by 2. So this is 1 plus minus, this is root 9, right? So this would be 3 by 2. So one answer is 4 by 2, which is 2. And then one answer is 1 minus 3 by 2, which is minus 1. Yes, correct, guys. Right, so P would be 2 and minus 1. Okay, now we are getting two values. So this is 2 and minus 1. So you guys tell me that if I have p equals to minus 1, right? And my t square is p. So what is t?
Sir, root p.
Root. And if I take p equals to minus 1, so what is root minus 1? This is
an
imaginary,
imaginary number.
right? So then this minus 1 is discarded, right? So which means that p equals to 2. So t is root 2. Is that clear, guys?
Yes, sir.
So now this guy was the culprit, right? So this guy made us roam around everywhere to get this guy. So now we have gotten this guy right. Now we can put the value of this t in here. So a would be what? This would be root 2 square minus 2. So this is 12 into 2 minus 2. So 24 minus 2, which is 22 meters per second square. Any doubt in this question?
No, sir.
Yeah, then you guys, so this was a very easy looking question, but it had some twist and turn. So this was the twist, right? You guys note it down, and if you guys have any doubts, so please ask. Always remember that we have to reach where? What is the quantity that we need, right? And yeah, so exhaust all your mind to get that right. So in this question, this time t was the guy that we
Finish, sir.
finished noting. Okay,
Yes, sir.
com mm, means you have completed this part also.
Yes, sir.
Okay, Rishida, Martin, and Khudeja, what about you guys?
Yes, sir.
Martin, what about you? Yeah. Okay, Martin's mic is not working. And Khudeja, so this is her first class, that's why she is hesitant to reply. In the chat also, she is hesitant. Khudeja, you see, we are friends here, right? So no harm in talking or writing in the chat box. Okay, if you don't understand, so then it's completely all right. This is 11th standard, and I can totally understand that if you don't understand something, right? So in my 11th class, I got very few marks. So yeah, and you guys can only improve if you guys practice hard and revise a lot. So this is my advice to you guys. Okay, let us do this 14th question. Right. So the relation between time and distance. Now this one is easy looking question. Relation between yes. Oh, you are having internet issue. Okay, no worries, no worries. Yeah. So yeah. So alpha x square plus beta x. Right. So generally, but generally when we calculate the uh, velocity and acceleration from distance. So generally what is given? Generally what is given when we
Velocity?
no, when we calculate the velocity and acceleration from distance. So generally the distance is given like this. Am I correct? This is given like t square plus something or something like t cube plus something like that. Right. So x is
Yes, sir.
given as the function of time. Right. But
Yes, sir.
but in our question, so then we can calculate velocity, which is dx by dt. Correct?
Yes, sir.
Correct, guys. So now, but in this case, the time as a function of distance is given, right? So either what we can do is that we calculate the x as function of time in this equation, right? Which would be very difficult. So if we write x square plus beta x equals to this is t, right? So we cannot write t x as function of t in here, right, guys?
Yes, sir.
We'll have to make it perfect square. We have to add something and subtract something, and then so it would be very difficult to make this a perfect square, right? So we'll have to, yeah, it would be difficult. So firstly, you'll have to divide this by alpha. So this is alpha x equals to t by alpha, and then we'll have to add or subtract in this equation. So then we'll have to, this is 2 a b is beta by alpha x. So this would be x is x, and then a is x. This is b, so b would be beta by alpha into x, x cancel. So this would be b, and then add. So I'm just I will do the other method. Just for the simplicity, I'm telling you guys. So this is no need to understand this part. So b square, and then we, right. So this is t by alpha, and then what we do is that this is what? This is a square plus 2ab plus b square. So this is x plus uh, this whole square, right? And then this square we get in the right hand side. So this is beta by 2 alpha square. Okay, then this is square, so then we take the root. So root of t plus beta square by 4 alpha. So x we get this is t plus beta square by 4 alpha minus beta by 2 alpha square. This is square. So now this equation is in the form of t. Am I correct?
Yes, sir.
But this is a very lengthy process, right? We exhausted so much of our time, right? So no need to understand about this part. Now we have x, then we can calculate all the other things. But we have an easy method, right? So forget about this part. We have an easy method, and what we do is that, yeah, let me detail about it. So what we do is that we take, so v is simply dx by dt, right?
Yes, sir.
So what we do in here is that we simply just differentiate all these terms by time. So differentiating it, yeah, this is first equation, differentiation first with respect to time. So in hand left we have dt by dt, and then we have d by dt of whole quantity. So this is alpha x square plus beta x. So this is dt by dt is what, guys?
1.
This is 1, right? So and then we take the alpha is right. So this is 2x, and then dx by dt. Okay, and then this is simply beta dx by dt. So this is the answer. Did you guys understand this part? So we
Yes,
had
sir.
d by dt of alpha x square, and we put alpha outside, and this was d by dt of x square. So x square is algebraic function. So when we do the differentiation, so this would be 2x, right? But
Yes,
inside
sir.
but inside we have this function also. So then we'll have to also take the different chain rule, right? So then we'd also have to take the differentiation of this quantity. So this would be dx by dt. Understood? Whenever we have something like this differentiation, dt square plus 4 power 3. So first we do the differentiation of this algebraic expression. So this is square. And then by chain rule, we take the differentiation of the inside function. Correct?
Yes, sir.
So similarly, in this part also, the function is x, but this is algebraic function. So first we do the differentiation of algebraic function and then the inside function. So this is what we get. Clear?
Yes, sir.
Okay. Then what is dx by dt? What is dx by dt, guys?
Sorry, sir.
Dx by dt. What is dx by dt?
I told you dx by dt, right?
Yeah, dx by dt is what? V.
V.
So beta v. Then we can calculate or take common here. So this is 1 equals to 2 alpha v is common. So this is 2 alpha x plus beta. Okay. So this v is what? This is 1 by 2 alpha x plus beta. This is our v. So did you guys see this? Is this the easier method or the previous one that we were doing? Which one was the
This one, sir.
this one, right? So we have calculated now. We have calculated the velocity, right? But in the question, what they are asking, the relation between this, the retardation is what? Okay, so they are asking about the retardation. Okay, so we have calculated the velocity. So how can we calculate the acceleration? How
Sir,
yes,
differentiation.
differentiation. So A is dv by dt, right?
Yes, sir.
Now you see this v is function of time or distance. V is function of time or distance from that relation. What can you say?
Distance.
Distance. Absolutely correct. So yeah, keep that in mind, right? So this is d by dt of 1 by 2 alpha x plus. You guys calculate this differentiation and tell what do you get. Please calculate and tell. Are you guys calculating?
Yes, sir. Calculating.
Calculate and Yes, guys, what do you get? Got disconnected. Learnivio got. Sir, minus 2 alpha b. Okay, so Akib is getting minus 2 alpha b. Rishita, Martin, and Khudeja. What you guys get? Good, good. So yeah, let me write and you guys check whether it is correct or not. So this is d by dt of this one. So this is d by dt of 2 alpha x plus beta and power minus 1. Am I correct? So
Yes, sir.
this is power minus 1. So algebraic function. So this would be minus 1 and 2 alpha x plus beta and then minus 1 minus 1. Correct? Is this correct? Rishida, Martin, Khudeja, Akib, is this correct?
Yes, sir.
Yes, sir.
Now we have this function again. So using the chain rule, d by dt of what is that? 2 alpha x plus beta, right? So this is minus 1 and this is minus 2. 2 alpha x plus beta and then minus 2, right? And then d by dt of 2 alpha x plus beta. Constant differentiation is 0. This is 2 alpha dx by dt. So we will get what? This is minus 1 divided by 2 alpha x plus beta square and then 2 alpha. Okay. What is 1 by 2 alpha x plus beta? 1 by 2x x plus beta is what? V. So this would be minus of v square into 2 alpha. So this would be how much? This would be minus 2 alpha. This is acceleration. Any doubt in this, guys?
No, sir.
So they are asking about retardation, right? Retardation is negative of acceleration. So this is minus of minus, which is 2 alpha. So this is the retardation. So if you guys have any doubt, you can ask me and please note it down. So 2 alpha, this, please note it down.
Yes, sir.
And if you guys have any doubt, so then again also ask. Whenever you guys want me to say
Finished, sir.
something, finished. Yeah. So this one also.
The last part.
Rishida, Martin, and Khudeja, what about you guys? Yes. What about you guys? Done.
Yes, sir.
Okay, so let me erase this one and let me talk about the next one. Okay, so the 15th one is the same, right? 15th one is the same, so I will skip that, and 16th one is also the same. So you guys take these two questions as your homework. Okay.
Yes, sir.
And what is the other one? Okay, this one is also. So take you have 1 week, so this one also. Take a screenshot of these questions.
Yes, sir. Taken.
Yeah. Martin, Rishita, and Hudeja, what about you guys? Take it. Yes, Rishita. Take in the screenshot, guys.
Yes, sir.
Now let us do this next question. Okay. So this question is telling us that two particles are 100 meter apart. So before I do that, this question, right? Before I do this question, let me talk about the side. Okay, so uh, kinematics we have talked about. The idea is that what is the relative velocity? Relative velocity in one, right? So it happens when both the objects are okay. So let's say that this is A object and this is also B object, right? Moving in the same direction. So this one is moving with B velocity and this one is moving with A velocity. So relative velocity of A with respect to B would be what? This would be VA minus B. Okay. So this is what we call the relative velocity. This is called the relative velocity. Understood, guys? So let's say that this is I, right, and this is also I. So this will be when I take VA minus VB. So let's say that this is 50 meter per second and this is 30 meter per second. So when I calculate the relative velocity, so this would be 50I minus 30I. So this would be 20I, right? So whenever the objects are moving in the same direction, then the velocity which will appear, which is the relative velocity, so this would be in the same direction, this would be just minus, right? Magnitude minus. And when they are moving in the opposite direction, so let's say that this is VA and this is V. So when I calculate this VA minus VB, so this would be how much? So let's say this is 30, this is 50 meter per second, and this is 30 meter per second. So VA is 50 I, and VB is what? VB is what? Akim?
Sorry, sir.
VB is what? This is moving in
30. Minus I cap.
minus 30 I, right? So this would be I cap. So this would be minus of minus 30i. So this would be 50i plus 30i. So this would be 80i, right? So you guys saw that whenever the objects are moving in the opposite direction. So in opposite direction, magnitude just add up. So V relative magnitude is simply A magnitude plus VB magnitude. Is this clear, guys? So just remember that whenever we are moving in the same direction, the speed will appear to be reduced, and whenever the objects are moving in the opposite direction, so the speed will appear to be enhanced or increased. Clear? Is this clear,
Yes,
guys?
sir. Clear. Yes, sir.
Okay, so now let us do this question. So we have two particles are 100 meter apart and start approaching each other. So we have two particles, right?
Yes, sir.
So this is, let's say, A. This is going in this way. This is B, which is going in this, right? So A is 2 meter per second, and B is 3 meter per second. So what would be the relative velocity magnitude? What would be that?
Sir, A minus B.
Yeah, A minus B, but they are in opposite direction. So what would be the relative velocity? Magnitude. I'm asking about the magnitude. So I just told you guys a moment ago that whenever they are opposite, so the velocity add up, right?
Yes, sir.
So this would be 2 plus 3, which is 5 meter per second. Is this clear?
Yes, sir.
So now this is the velocity, and how much is the distance that they have to cover? What is the distance between them? 100 meters, right?
Yes, sir. 100
So
meters.
D is 100 meters, right? So what would be the time? What would be the time?
Sir, you have to degrade.
No, no, no. Forget about the integration. This is not the parametric form. They have not given the how the distance is related with some time and right. So this is actual distance, right?
Yes, sir.
So they have already given you the velocities and the distances. So forget about, we are not calculating the instantaneous, and so this is uniform motion, right? Speed is same, and yeah. So what is time? This
Sir,
is,
distance by speed.
yes, distance by speed. So distance is 100, and velocity is 5. So this will,
20 seconds, sir.
is this clear to everyone?
Yes, sir.
Right. So yeah, this is how we do this problem. Whenever whenever the two objects are moving, two particles are moving, then we apply the relative velocity idea. Okay, so there is a question like this also, that two trains are traveling, right? So this is one train, right, and this is the other train, not on the same, not on the same railway line, but on. So let's say this one, right? So this is something like this question. They are traveling and they are in the opposite direction. So this has some length, let's say uh, 20 meters, or let's say 50 meters, right? And this has some length, say 30 meters. Okay. And this one is traveling with 50 meter per second, and this is for 60 meter per second. Okay. Then if we want to calculate that, what would be the time to cross each other? Time taken by the trains to cross each other. So this is what kind of concept, or what concept we will use? What concept we will use, guys?
Uh, the same one which we used for particles.
Yeah, same one, right? Because whenever you see two objects are moving, then we apply the relative velocity idea. So we will apply the relative velocity. So they are moving in the opposite direction. So then the velocity is simply 50 plus 60. So this would be 110 meter per second. So the overall velocity with which they are traveling is this. Clear?
Yes, sir.
And to cross each other, they have to complete how much distance? To cross each other, they have to complete how much distance?
Sir, the total distance by velocity, total velocity.
Yeah, that is correct. Total distance. So how much distance they have to cover when they want to cross each other?
110 by 30?
No, no, no. So this one is this length, right? So
Yes, sir.
they have to cover this 50-meter distance as well as this 30-meter distance. Then they will
So
cross
80
each
meter.
other, right? So the total distance that they have to cover is 30 plus 50. So this is 80 meters. Clear, guys? Is this clear?
Yes, sir.
So the time that it will take to cross each other would be 80 divided by this 110. So 11 by 8 second, which is which is point something like nearly 8, right? So something, let me write this as 38. So then this would be 38. So this is 80, right? So then this would be how much? So this is, to simplify the question, I just changed the question a little. This is 110. So this is 0 point, or this is how much? 0.8. Clear?
So it will be 0.8 seconds, right?
Oh, yeah. So this would be, let me, okay. So this is, yes, 0.8. So this is into 10. So this is 8 by 10, which is 0.8. Right? Seconds. Yes. Is this clear to you guys?
Yes, sir.
Yeah, please note it down. Please note down this 32 problem and this one as an example. Please note down this problem. And then we'll start. So this is completed. Then do we have any more questions? Okay, we have this one, but this is not. So this is same questions. These are same questions. So in the next class, we will do the uniform acceleration. Please note down this part.
Yes, sir.
And whenever you guys have completed a tell. So this is a train problem.